Well, back again, and if I sound strange, it's because I've got a cold, but I'm doing this a bit out of sequence, but the idea is that I've completed all the test bed demonstration and now going to use the same idea and apply it to my pedal board, which I'll put at the start of this video to demonstrate my pedal board. But this is my controller unit that I'm going to put on my pedal board, at least where I'm up to. I'm ready to put it together. So I've done all the work constructing the thing, which is really just working out what you want to switch and where the layout of everything's going to go. So that can be quite tricky, and you've got to measure everything in space. But basically the way this is going to construct is out of these aluminium sections. So it's going to form a pedal board that is constructed like this. The space thing. There are these wooden sections here. These two here, the end pieces, have these flanges that are going to screw to the pedal board, and they have these cage nuts here so I can screw it down on top. So what's going to happen is the middle section here, which I've constructed to allow for cable through here, and there's a harness or array that's going to connect to all of that. That has the wire. There's the Arduino Nano board and a few other connections that'll have an input-output jack sort of module here, I guess, which will eventually be what should I say? Will be attached there by using pop rivets. My brain's not so good today. Yeah, so the idea is that this middle section will tie these two together, and that'll be one unit that'll lift off and onto the pedal board onto these, and it'll be held down onto the pedal board. Firstly, the two end units will be held in by screws in the flanges, and these will be held down by these thumb screws here. So I can just undo the thumb screws, lift it off, and get access. And when you build your own stuff and you want to do modifications, that can be really handy to have. The other thing, this wiring harness, which is going to be situated under here, like this, I should say, that will be connected here, and these will rivet to the top of this one, and this is, I've already pre-populated with all the DuPont connectors on the Arduino panel board, plus I've attached the USB mini to USB, what I call this type B, I think, that's used a lot with printers and musical instruments. So that's going to be attached there, and eventually that'll be panel mounted here to allow uploading and modifications to the program. So I'm just at the point now, having worked all that out, and I didn't film it because it takes such a long, it's all trial and error, it takes such a long time to do it, but everybody would have their own solutions, and like most of these things, when you finish it, you realize how you would do it differently next time, but there never will be a next time. That being said, I've done this numerous times, and I guess maybe learned some things along the way. So just to start putting this together, the first thing I'm going to do is connect this centerpiece here. So what I do is I lay out all my components on a piece of foam like this to start with. It actually makes life a bit easier. And one tip, and I'll try not to spill anything, but you see by these resistors, they're on these wax strips here. Sorry, paper strips here for machines. So I just stick them in cut the end off, stick them in the foam, and then cut the end off like this, and we're ready to go. almost pulled a couple out there. So that's easier than just fiddling around too much. So there's 11 of those, because there's, in this array, there are 10 switches. Some of these have numbers on the bottom, because I've repurposed them from prior projects. There are 10 switches for switching a number of things. Let me get this down before I make a complete mess of this. 10 switches, 10 LED, they're the LED bezels there. But the way I'm doing this is not all of the switches will be actually doing MIDI controls. There'll be one switch down here for a boost control, which is using the external remote control of another unit, Matsume dual compressor boost pedal. And there'll be another switch up here that's going to use a separate module I have for controlling my delay, and only the switch will be here. I'll mount LEDs in all of them, but not all of them will be in the program for the Nano or doing MIDI switching. So I'll start at the beginning. The first thing is to put these screws in. So I'm constructing it first, and then I'll put all the components in second, because that way you know that it's going to fit in. Just put that in. It's going to fit in properly, rather than the other way around. I've worked that out as best I can up to this point, but this is the first time I've actually constructed the whole thing together, so no doubt there's going to be something wrong. So I'll just put that second screw in. This aluminium's only 2mm thick, so it's not that easy to completely countersink the screws, but it's a reasonable approximation of where it should be. Right there. Right, we'll see if we can get these in. Right. Make sure that's squeezed up. Before I do that, one thing you'll notice is I slightly rebaited this middle one. You can see on the side there, it's slightly rebaited there, because this bottom component panel for the switches is not fixed at these ends, so I want the middle one to spring this down a little bit, so they're not going to be, doing that every time so it's just putting a little bit of downward pressure on it, just enough to stop these flopping about when I use them, because it doesn't need to be fixed to it to give it strength, but what am I doing? Talking and this is exciting, isn't it? That's got it. Also, all my sensors are a bit, with this cold, are a bit dull, including I've got bleary eyes as well. So anyway, all right. So all things being equal, we've got one integral unit, and It's just a matter of now I'm going to mount all the switches on here, like so. So I'll mount those switches sideways like that for connecting. I'll put all the LED bezels in. So these are 6mm holes, and I'll insert. Let me say I've laid these LEDs out as they're going to be as I want them to. So this one's for the delay that won't get used, and I'll be putting all the LEDs in, which I didn't do that completely, but it'll do for now. So all the LEDs will go into the whole setup, and I will try to do the same convention all the way through, which is the positive leg, the longer of the two legs, if you can see that there. The longer of the two legs I'll put to the outside. I'll be running a common supply to it, and the control, the negative for the control to the Arduino board will be mounted there. Once I've got all of those mounted, I'll then do the common wiring for the each of the terminals, the common terminals for the switches, and the common positive for the LEDs. Then I'll mount this component here that has the nano board on it, and we'll also have the input-output jacks. So there's a MIDI connect 5-pin DIN MIDI, a power in, and two phono jacks. One will be for the boost control, and one will be for the delay control, which will make sense when it's all installed later. So I think that's it for now, and I'll just do all that off camera, and we'll come back when that's more populated. Well, here we are back again. I've done the first part of the wiring and populating all the components. You can see all the switches are in, all the LED bezels and LEDs are in place. If you look under here, a couple of these LEDs are from collect stuff I've had in the past. A couple of these aren't quite the right spec for the bezels. They just won't stay in, so I'll put a couple of cable ties around to hold them in. But what I've done here is just the common connection. So I've got a common positive connection for all the LEDs with their resistors. So it's like a little bit of a branched network where there's a common wire positive going to each of the positive legs of the LEDs. That wire, they're all meeting at these two common points here is where they're going to be the like a bus or the main connection for the positive and negatives for anything else I'm using. Obviously I have to insulate that a bit better, but they're going through the wiring cavity there. So the wires are then going down to this, which is the common connection for these three. So it just comes in the middle for those two LEDs. I just looked at that one there. I think I need to I'll just do that one a bit better there. Oh, sorry, off camera. You can see that's hanging on by thread, so I missed that. But and the common connection here with the LEDs, and then all the switches have a common connection for one of their lugs all the way through. So you can see a couple of the switches. This one here has no wire to it, and neither does this one here, although I've put a wire in place here in case I ever did want to connect it in the future. But looking at the way it'll work in practice, that's my boost for my external unit. That's going to be the external unit, and that's my delay module. So they don't have connection. Even though I've wired up the LEDs, they'll never operate. You can see it looks a bit. I'll just put that in a bit. It looks a bit flimsy, but once these things are wired in place, and you mount it on the pedal board, not much goes wrong with them. They're not. Yes, they'll get a few knocks, but you have to try pretty hard to stuff these things up. So I've just finished. There's a couple here I can see. I'll improve a little bit as far as connections go, but the rest of them look fine. The next step will be to do the connections for the control terminals on the Arduino for all the LEDs and all the switches, and to put that do the connections here for this input output panel and power in. So those two, and I'll go through that in the next video. But there it is, starting to look like something that'll do what it's supposed to do. I've tested all the LEDs and all the switches, they all work, so that's good. So moving on to the next stage of this controller unit, having put all the common controls for the negatives for the switch and for the LEDs, now moving on to the messy business of setting up the control terminals for each of the switches. So I've done a bit of testing offline and worked out where the switches should go. And I know, because I've used these gangs of DuPont connectors, I know that once I pick the first one on the sequence, for example, I know I have to connect 8 switches because I'm only controlling, having MIDI control for 8 switches. There's 2 other switches that are controlling outside or external functions, not MIDI controllers, but they're on the same board. So once I get the right connection for the first wire, which I know, for example, I've already figured out for this one is this red wire is switch number 1. Then I just need to look at the array, which and go through in sequence and say, okay, red's number 1, brown's number 2, black's number 3. If you can, I keep catching my soldering iron. If you can see that the way that's working there in those arrays, and just work my way through like that. And that's what I'm going to do now. So I'll just do the first one here. For example, I've worked out that, yes, it is red number 1. I found a way of routing this wire through over here. I'll just put it through under here. And I'm going to wire it onto this terminal here. So this is always going to be a bit messy, this wiring, because it is do it yourself and there's no circuit boards. So I'm going to cut that off. So there's a few tools. You should have wire strippers, wire snippers, this kind of tweezer holding tool with flat blades, and I forget what these are called. It's a medical scissors, dialysis scissors. I don't know. It's not a dialysis machine, but the name escapes me for what these are. But these are very handy for just clamping onto wires and things and being able to get them into tight spaces. So those kinds of tools are very handy. So I'm just going to do the first one here, and I'll work out, yeah, that looks about right. Snip it off there. strip the wire, give it a twist, get my soldering iron, bit of solder, tin it. I forgot to turn my fan on, but I'll do that in a minute. Stop me breathing those. Usually end up with too much, and quite often the insulation on these small wires will shrink back a bit when you solder it on. But I usually find easier just to grip it with this, sort of get the wire orientated the way you want. You want that to bend. I want that to bend up and be pushed back down to the. I haven't got the right grip on it. Right, that's back down to the bottom there. Keep it out of the way, and that's on. Oops. Didn't wait long enough for the solder to dry out, to solidify again. Soldering is generally pretty straightforward like that. Sometimes you need to get some solder on your tip to be able to get the right heat transfer. Sometimes there's just some impurities or something that causes the solder not to work properly. Generally, the thing to do is to work it as hot as you can get it with as short a time as possible. What you don't want to do is linger too long on the unit and get heat transferred into an arrangement like this where you've got metal in plastic, and the plastic melts the metal and it becomes less functional, has problems, whatever. But hot and fast, if that's not too racy for people, is the best way of working. The thing, it's sort of counterintuitive. You think if you work just, I can control the temperature of this. If you worked at a colder temperature, it'd be less likely to damage. No, you want to melt the solder as quickly as possible here, and have as little heat transfer as possible. Anyway, I'm not an expert in soldering. I'm sure people know better than me. But anyway, I got distracted talking about soldering because I've had so many mistakes. And if you're like me, where I'm reusing components, you want to make sure that you're not that every time you're soldering, you're not causing more distress to the unit, heat distress. From here, I'm going to solder all the rest of these control wires to the 8 switches, and then I'm going to do the equivalent for the LED connections. Then I'll do a test of how it works, and I'll then do the final wiring for the outputs. And I also have to fit I forgot to set up a reset switch, so I'm going to fit a reset switch in. But apart from that being a bit of a mad nest of wiring at the moment, it's coming along quite nicely, and it's a reasonably neat arrangement. I've also put in the USB connector here, so that is going into. Let me just have a look up here. You can see it's connecting into the nano board there. All the DuPont connectors are in there. Just push those fellas down a bit. And that has been panel mounted there. So I can connect in, and I'll put a reset switch over this side somewhere. And away we go. The final construction now, I've put everything together, and whilst it looks like a mess, it's all been tested and it all works. I've configured the output section, including the MIDI power and the 2 external controller units, and now all I need to do is rivet this in place. I'm going to put a bit of tape over the top just to make sure there's no, do the way it's going to go in like this. Make sure it doesn't earth out or cause some unnecessary connection. And of course I don't want to go over the holes I'm supposed to rivet. Alright, so now it's just a matter of slotting all these wires in here and rivet this in place. So first rivet. Let's get that. Alright, done. I do have a little retainer here. Just to keep these wires in check. And just cooperating like it should. I need my other screwdriver. I'll screw that in. My other screwdriver's not here right at the moment. I'll screw that in properly. And I've added back in the thumb wheels here. So this, I will eventually put some plate over here. I've mounted the reset switch here, which you might be able to see in there. So it's recessed in there so that I can't accidentally kick it, but I can push something in there to press the reset button if I need to reset the whole board. Don't really need to do that very often. Usually power off and power on is good enough. Yeah, so I will put some kind of plate across there, but that's ready to go onto my pedal board now, so that's it. So here's the finished product. I'll finish mounting the new controller unit on my pedal board, and if I can just plug that in, you can see it lighting up. So it works. All that LED's bright. It works as designed. I'll just go through the switches. So the first one is down here is my boost switch. You can see that's remotely switching the boost for the NUX Maxime, which is what I wanted. Then these switches here, it defaults to 1 when it starts, boots up. It goes through 1, 2, 3, 4. Back down again. You can see the patch numbers changing on the Chase Bliss unit as well. 3, 4. So there's sort of my clean to sort of chimey edge of breakup settings, and the reason I have those four is tube amps are fickle, and sometimes one patch is too clean, another time it's too dirty, so I just pick whichever one of those suits me at the time. Plus I played two different guitars, and they're a Gretsch 6120 and a Duesenberg Starplay Deluxe, and their pickups are all over the place in terms of their output. So That's one thing. Now going up at the top, I'll skip this one. This is overdrive 1, which is patch 5, and overdrive 2, which is patch and a higher gain overdrive, and this is patch 8 is the fuzz. You can see this button here is the fuzz. There's internal switches when as it comes by default. The fuzz is almost unusable. It's so wild, but there are internal switches to bring out control. So this is when you want something really high gain. The other functionality is this is the bypass switch. So you'll see this is the bypass light here for that unit. So that'll control the bypass, but also you'll see that I was on patch 8. When I push it back again, it comes to patch 8. So what it does is, so I'm trying to make this intuitive. When I push the bypass, it says, right, nothing's active. You won't see anything displayed here on this pedal board to say that you've got using anything but straight through to the amp. And when you push it again, it comes back to being active and saying, yes, you are on patch 3. If I turn it off and then I say I want to go to patch 6, 5, I should say. Looks like I missed it. It'll switch this back on. Looks like a little bug to fix there with turning it off with patch 6. But certainly, if it's off and you press patch 5, it'll come back on. A little bit of coding to be fixed there. So I'm just working out the bugs. So I finished finished it off with a little bit of trim. This is a bit of Tas oak that I had left over, and I thought that'd a brass screw, so I thought that'd look good. With the Chase Bliss has got its own wooden trim on the side, so there you go, aesthetically pleasing. Like most pedal boards are for function, not for looks, but there you go. You can see I've got the USB connector there, and I have put the reset button in there, so if you push something in there, you can press the reset. Not so necessary really, but there you go. So overall, it's turned out pretty well, and like all these things you do, it's easy to make mistakes. I measured this, and I said, "Oh yeah, I'm going to have." If I look here, I'm going to have about a 7 meter, maybe even 15 mil to spare. But then I forgot that this unit takes up a bit more space. So, I forgot one more switch, which is this one here. This is the delay setting. So you turn this on, and then we have our relay-driven unit to do the tap delay. So you press this once for fast, again for medium, and again for slow. And what it's doing is just turning relays on and off. So that's working from the pedal board here as well. So there's actually a separate Arduino board in there running all that with the relays, but I've just connected it through to here. So that's it. That's the end of the whole setup. Unless I make any more modifications or need to make any changes, I'll see how I go with this. I don't play very often, but I've got a couple of gigs coming up in the next few weeks. And I'm in one of the bands I've been in the past, but we've had a long break and we're just starting up again. So I've got some rehearsals to do, so it'll give me a chance to test it out in a couple of days.